Okay. Hey guys, how's it going? So, we are gonna move on with our ionic naming shenanigans that we're going about doing. What are we gonna be talking about today? We're gonna talk about something called polyatomic ions. Last time we were talking about kind of binary ionic compounds where you have like sodium and chloride. Those ions, the sodium ion and the chloride ion, are both single atoms, right? Now we're going to be talking about something called polyatomic ions. So poly means many, atoms, atomic means atoms, and then ion means it's an ion. So what we have here is a huge list of these polyatomic ions. These guys are actually covalently bonded. They have these sharing electrons back and forth. But this guy, Br04, this entire thing has a charge of 1 minus. Okay? So this entire thing is kind of like a really giant ion that has a -1 charge. Okay, so that's what all of these things are. These are just think a bunch of atoms that are covalently bonded together. They're sharing electrons, but the entire thing, all of it together, has a -1 charge. Some of these guys have a -2 charge. Some of these guys have a -3 charge. And ammonium here, it has a +1 charge. Okay? Now, if this entire thing has a negative charge, then you can imagine that let's say this nitrate here. Okay? This nitrate, NO3, has a 1 minus charge. If a sodium atom came along, it's going to be attracted to this NO3 in the same way that it would be attracted to like a chloride ion. It's the same -1 charge. So you can go through and have an ionic bond happening between a positive charge like sodium and a negative charge like this nitrate. So we have a sodium ion and a nitrate ion. Here we go, nitrate ion. So they can bond together just like any other negative ion can bond with any other positive ion. So here is a big long list. This big long list is something that we're going to be using quite often in the same way that we have, Java. In the same way that, I don't really want to test you guys on, like, what does NA mean? In a similar way, I don't want to go through and test all of these guys. If this were class, I would be able to hand you a piece of paper to put in your notebook saying, here is the polyatomic ion list. Look at it, keep it in your notebook, and you'll be able to use it on exams and things. So there's that. The fact that you guys aren't here means that you're going to have to print this out on your own or copy it into a notebook or something. I'll try to make sure that you have a copy of this available for you. So here's this. I would suggest like either screenshotting this or honestly just Google polyatomic ions and you'll find a chart similar to this. So there's that. So let's go through and talk about these polyatomic ions a little bit. There's a certain kind of nomenclature with these guys. Okay, you may notice all of these guys on this side: bromine, bromate, chlorate, iodate. These are all your halogens. Okay, and they kind of come in. Each of them come in 4 flavors: either 1 oxygen, 2 oxygens, 3 oxygens, or 4 oxygens. All of them have a 1 minus charge. Okay. Now, depending on how many oxygens they have, is they're named differently. So let's start kind of in the middle here. Okay. We have bromate and bromite. So 8 and ite. This is going to be common among all of these guys. So the 8s have 3 oxygens in it. Ites have 2 oxygens in it. And you can see that's the same thing over here. Nitrate, nitrite, 3 oxygens, 2 nitrogens. Sulfate, sulfite has 4 and 3. Sorry, it's going to be a little weird. Phosphate, phosphite has 4 and 3 as well. The way I remember this is 8. Oh, I ate a big meal. It has more oxygens. Okay. Or I just had a little bite. I just had a little bite. A little bite means smaller amount of oxygens. Okay. And the way I remember sulfate and phosphate have 4 and 3 is that these guys have bigger charges, so they're going to have more oxygens. That's the way I remember it. These 1 minus charges, the 8s and ites have 3 and 2 for that. Okay. Now, let's say we go up and get a even more oxygens than 8s. Okay, even more oxygens than 8s. Well, you add a per in front of it. So per brom 8. So we know it's 8, a lot of oxygens. Per means it's even more than your normal amount, Br4. And you know it's a Br because it's a bromate. There we go. So that's kind of the process here with these guys. Chlorate, well, I know 8 is more oxygen, so it's going to be O3. If I said perchlorate, it's ClO4. Okay. And then same idea going down. Ite, hypobromite is BRO, the single oxygen. So hypo just means like below, less than. So if it's less than an ite, it has to be less oxygens than the ite. So there's that. Okay. That's kind of the naming scheme they have there. What else? Nitrate, nitrite. These guys are going to be very common. Hydroxide is going to be another very common one. Hydroxide you can remember because hydro, it has a hydrogen. Boop. Oxide is an oxygen. And it's an ide, so it's a -1. There we go. Cyanide is CN. Cyanide, CUN. Cyan, like it has a C and an N in it, so it's a CN. Thiocyanate, well, it has a cyanide thing in it, so it's a CN, but you add the thio and you add a sulfur on there. Okay. Yeah, there's a whole bunch of these. Again, these are some that I want you to be familiar with, at least familiar enough that we can talk about it and you kind of know what I'm talking about. So yeah, there's that. Ammonium ion, this is one that you probably should know off the bat, is NH4 1+, because this is the only positive polyatomic ion. So ammonium is that. You can kind of see where this naming scheme comes. It's ammonium, right? Ium. So kind of like sodium or potassium or calcium or cesium. All of these are going to be your positive ions. So, all right. So there's that. So if I wanted to go through and let me kind of pop out of this. Burp, burp, burp. Okay. If I wanted to go through and write something. So let me go through and do, let's say, calcium nitrate. Okay. So if I'm looking at calcium nitrate, well, I know there's going to be a calcium and I know it's going to be a nitrate. So then I would go, okay, there's nitrate. There's my NO. So it's going to be NO3. And I'm going to put parentheses around this NO3. Okay. That way I know that this NO3 is actually just one thing that's all together. Okay. Then we can do the same thing to figure out the formula for these guys. We do the exact same thing. Calcium is 2 plus, and nitrate is 1 minus. 1 minus. And so that means that I'm going to need 1 calcium and 2 nitrates. Okay? So this is a good reason why we have these parentheses here, is because we have we know that there's 2 NO3s. There's 2 separate NO3s in this. This is not going to be the same. So let me go through. Not the same as saying N2O6. Okay. We have 2 completely separate NO3s. All right. So there's that. So that's how you go about finding, the chemical formulas. It's exactly the same as before, except you just put parentheses and put in whatever your polyatomic ion is. So for example, like sodium hydroxide is another one. It's going to be sodium, Na, and then hydroxide, that is an OH. Okay, so they're both 1 and 1, so that means 1 sodium and 1 OH. This will be your chemical formula. Okay. Let's do something like, how about sodium sulfate? Okay. So sodium, Na, Na, and then sulfate, SO4, is going to be our sulfate. And sulfate has a -2 charge. So I can go ahead and write that 2 minus, and this is 1 plus for the sodium. So that means I'm going to need 2 sodiums for every 1 sulfate. And here is my chemical formula for sodium sulfate. All right. So there's that. All right. And we're going to have one more, add one more wrinkle to this. The next wrinkle is going to be, what do we do with these transition metals that can switch up different charges? Like iron, I mentioned in the last video. Iron can have a 2 plus, a 3 plus, or a 6 plus. We don't know which one. So it's going to be hard for us to say iron oxide, because we don't know at that point, is this iron 2 plus? Is it iron 3 plus? Is it iron 6 plus? Who knows, right? So we have this naming system down here. We use parentheses and Roman numerals when we're writing out the name. So iron parentheses 2 oxide, iron 2 oxide. What this 2 represents here is what's the charge of the iron, okay? And iron 3 oxide is going to be iron 3 plus. All right, so let's kind of think about this for a second. Let's write out the chemical formulas for this. Okay, so for iron 2 oxide, we know we're going to have an iron, and we're going to have an oxygen, because it's iron oxide. The oxygen, we know, is always going to have a 2 minus charge, and the iron, we don't know what charge it has, except it's in the name. It's 2. The Roman numeral 2. So we know that this is a 2 plus charge. So what are the subscripts going to be down here? We have 2 and 2. It's the same. Guess what? 1 and 1. We're good. We can just leave it FeO. Okay. Next one, though, if we say iron 3 oxide, we do the same process. Iron, oxygen, right? Oxygen is always going to be 2 minus. And then we don't know what iron is. Check the Roman numeral. It's 3 plus. And there we go. And with this, you can pull that crisscross trick. It's iron, this iron, subscript 2, oxygen, subscript 3. Erase the charges. And this is now our formula for iron 3 oxide. Okay. Hopefully that makes sense. Then you can also do this in reverse, right? you get the formula, you need to figure out what the charge is so you can name this boy. How are we going to go about doing that? Same idea. We know oxygens are 2-, but there's 3 of them, so it's a total of 6+, right? Or 6-. 6-. So then that means, since this is a neutral compound, we need 6+ to even it out. This is 6+, and come up here to cobalt. There's 2 of them, which means each of them are going to be 3+. So we know that the cobalt is 3+. So if I wanted to write this out, actually, I can type it out so I don't have, you know. Whoop. So if I wanted to write this, I would say cobalt, CO is cobalt, and then in parentheses, do a Roman numeral 3. And then finish it off with oxide. Cobalt 3 oxide. All right, so there's that. That's the video. I'm going to give you another assignment, basically just naming polyatomic ion compounds and using this Roman numeral system. It's called it's stock nomenclature. So that is going to be that. If you are having trouble with this, give me a message on Canvas. I can help you out. And there's that. All right, guys. Hopefully you have a good day. Bye.